Today, we're going to talk about forces. But first, what is a force? A force is what causes objects to move in space. When objects push or pull one another, it creates the force that causes them to move. They help us jump off the ground, walk, or even run. Some of these include gravity, the force pulling you and keeping you on the ground. Others are the forces of friction and the forces influencing linear and angular motion, which we'll be explaining later respectively. Friction is the opposing force created when two objects are in contact with each other, with at least one of the objects moving against the surface of the other, like the bookcase moving against the carpet. Friction is dependent on things like the weight of the object, as well as the coefficient of friction, which is a number given the two objects telling us how easy or how difficult it is to slide them against each other. Therefore, it is crucial to take into account the nature of both surfaces and how they interact with each other. For example, the coefficient of friction between the sole of your shoe and melting ice is very low, meaning you can slide easily. On the other hand, the coefficient of friction on the same sole shoe and grass alone is much higher, and therefore harder to slide through. Friction is everywhere. Without it, we wouldn't be able to do much. It is the reason we can pick up a cup without it sliding out of our hands, the reason we can walk, drive, or really do anything without just sliding off non-stop. Here at the park, we can see many examples of friction. It's here, and even here. To understand a little more about friction, we'll talk about it with respect to a slide. But first, we'll start on a hill. If you have someone sitting on a hill, as long as the slope of the hill isn't too high, friction holds the person back from sliding down. This is given that the coefficient of friction between the individual's clothes and the hill is high. So how can you make the person slide down? The goal will be to decrease the coefficient of friction. Something as simple as adding a skateboard allows for this to happen. Now, let's take the same individual and set him up on a slide. Although the person is the same, meaning the weight is the same, clothes is the same, we have changed the object that they're in contact with, and the new coefficient is much lower, meaning the individual can slide much easier than they did on the hill.
Let's talk about linear and angular motion. Sliding down a slide is an example of linear motion. Linear motion is when a body moves from one point to another in a straight line. Sliding down a slide starts at the top of the slide and then ends at the bottom of the slide in a linear path. But what about angular motion? Swings are a great example of angular motion. Angular motion is the motion of a body that rotates about a fixed point. The pendulum of a grandfather clock is another example of angular motion because it consists of a load rotating about a pivot point when a force is applied. When we look at the swing from the side, we see that there's a pivot point where the chains of the swing attach to the top of the swing set, and at the bottom of the swing is the saddle, where the person sits and produces force to operate the swing. This causes movement of the swing to rotate at the pivot point, achieving angular motion. We know that a great way to start the swing in motion is to simply push off the ground. Gravity then pulls the body toward the ground, but since Matthew's on a swing, we know he will remain on the saddle, and the saddle will stay attached to the pivot point by the chains, creating angular motion. It's important to note how this notion of center of mass is included when we swing. Center of mass is a reference point where the average of mass is concentrated at a particular location in or around a body. Take a look at Matthew, sitting on the saddle of the swing. His center of mass is located somewhere around his belly button. Center of mass is shifted as a body changes position, and this shift in center of mass can determine how a body responds to gravity. The changing body position influences angular motion when we swing. So let's try this again. First, Matthew will start again by pushing off the ground. But how does he keep the swing going in a back and forth angular motion? There are a couple things that he does. Holding onto the chains, he leans back and straightens his legs in order to go forward. To go back, he leans forward and bends his knees. Doing this allows him to use the center of mass to his advantage when he swings forward and when he swings backward. When he goes forward, he leans back and straightens his legs. This puts his center of mass slightly behind him, making gravity push him from behind toward the ground and giving him speed to swing forward. When he goes backward, he leans forward and bends his legs. This puts his center of mass slightly in front of him, allowing gravity to slightly push him from the front toward the ground and giving him a little bit of speed to swing backward. Repeating this will allow him to go higher until he wants to stop, which then he will place his feet on the ground and allow friction to slow him down to a stop.